Alright, today we're going to go over the 3.2 homework part 2. Starts on page 177, goes to 178. It's 44 to 84 even. Okay. Before we get started, there's going to be some important properties you're going to want to know. So, one thing, we talk about this idea of translating. So you're going to want to translate, be able to go from exponent form to radical form. That's what this property says, if you had to, just that translation. Then remember, we talk about matching bases. If you have matching bases and they're being multiplied, you add the exponents. If they have matching bases and they're being divided, that means you subtract the exponents. We talk about having parentheses. Parentheses mean multiplication, so I multiply m and n. If there's two things inside the parentheses, even if that's a number and a variable, that m goes to both. That's going to be a big one. It's like the distributive property for exponents. Happens with a fraction as well. M goes to the top and the bottom. So whenever you see parentheses, you should think multiplication. Remember, a lot of times we work backwards too. We take those matching exponents and we factor them out. That's another way to do that. And finally, we talk about negative exponents. You can't have a negative exponent. So that's how you get rid of the negative exponent. You just kick it to the other side. If that's negative, you move it downstairs. Everything gets moved downstairs. And if it's downstairs and it's negative, a and the exponent get moved upstairs to make it positive. There are important radical properties. Once again, translating is important. You're always going to want to know how to translate. If you can't translate, hopefully by now you're fluent and you think of radicals and fraction exponents as the same thing. Okay. Now remember, if you have the same index in multiplication, you can put it underneath one radical. Or if you have a fraction in a radical, you can take it to the top and the bottom. Remember, all properties also work from right to left, so you can break up radicals. Whatever. Remember, this idea is using whatever is best for you, whatever is there to make your job easier. Another thing, a lot of people, big idea of this section is I want to make matching exponents and radicals because that's how something gets out of the radical. All right. Also, don't forget that like radicals, say you have the same index and the same radicand, and that's how you combine radicals. All right. And also, don't forget your perfect numbers. So if you remember all that stuff, hopefully you can get started with this without any problems. All right, 44, we have y to the 4th to the 1/6. Since I see parentheses, I'm going to multiply those two numbers together. So I'm not doing anything with that y, so it's y. 4 times 1/6. If you do that in your calculator, it'll give you the answer right away, but I'm not. I'm going to do 4 times a 6, which is just 4/6. All right, and 4/6 can be broken down into 2/3, so that's my final answer. Now remember, we want you to translate that, so I'm going to translate that where I have a, m, and m, so I have the cube root of y squared. So there's the two answers I'm looking for. And that's it. All right, 46. The first thing I notice is I see a negative exponent. I'm not allowed to have a negative exponent. So I take everything that's down there and I move it upstairs. I don't do anything with the 2. 2 has no exponent, so it stays upstairs. That's why it should become 2 times x to the positive 3/2. I'm going to translate that into 2 square roots of x cubed. Now remember, x cubed, to get out of jail, you need a 2. So I'm going to rewrite this. I'm going to say, instead of x cubed, I'm going to put x squared times x. Okay? No n means 2. So if there's nothing there, the book will never write that little 2, but you can write that little 2 if you want. Now, x has the key to get out of jail, so he gets to leave. Remember, you have to give up your radical to get out of jail. That's why it's just x. And then this guy, he stays in jail forever, so that's your final answer. Notice, in this one, if we would have left 2x to the 3/2, you wouldn't have known that an x could have came out of the radical. We're going to talk about that a little bit more later in the week. All right, in 48, I see a fraction. So I'm going to take the radical to the top and the bottom. So this is going to be the cube root of x to the 15th all over the cube root of y to the 6th. Now, I'm going to take that x to the 15th and I'm going to rewrite it. I'm going to say the cube root That's 3x's, 6x's, 9x's, 12x's, 15x's. Y to the 6, I'm going to rewrite as y cubed times y cubed. Now, everybody who has a 3, all little 3's, cancel the base, leaves the radical. All right, so I have 1, 2, 3, 4, 5 x's that get to come out. So I have x times x times x times x, y times y, 2 y's come out, so I end up with x to the 5th over y squared. That's your final answer. Shortcut, divide 15 divided by 3 is 5. That's why it's 5 up there. 6 divided by 3 is 2. That's why it's 2 there. Okay, and that's it. All right, 50 is tough. I have the cube root of x times the square root. I'm going to put that little 2 there. The book won't write it, but I'll put it there. X to the 5th all over the square root of 25x to the 16th. All right. Book does not write index if it's a 2. All right, the book doesn't write that. So that and that, the book doesn't write. Now, I'm going to focus on this part first because I cannot combine. I cannot combine radicals on top because they have different indexes. So I'm going to put that, I'm going to just focus on the square root of x to the 5th all over the square root of 25x to the 16th. All right. I'm going to, and I still have that cube root of x there. I'm just not messing with it. I'm just kind of keeping it here. Now, x to the 5th is x squared, and x. So 2 x's come out, so I end up with x squared, x, all over. 25 is perfect. It's 5 squared, so 5 comes out of the radical. X to the 16th. 16 divided by 2 is 8, so it becomes x to the 8th. Notice the radical disappeared. Okay. Last thing I know, and then I have times the cube root of x all over 1. Last thing I see, 2 x's, those will cancel with those 8 to make it a little 6. Think about it this way. I have 2 x's on top, I have 8 on bottom. Two cancel, we're left with 6. All right, that's why it's x to the 6th on bottom. So this becomes the square root of x times the cube root of x all over 5x to the 6th. Well, I'm going to use my formula. I'm going to use my a to the mnth formula, and I'm going to rewrite these. So I'm going to rewrite that and that. I'm going to make it x to the 1/2 times x to the 1/3 all over x to the 6th. Matching bases. The reason I did this is now I'm matching bases, so I can add 1/2 and 1/3. I get x to the 5/6 all over x to the 6th. And then the last thing I'm going to do is I'm going to change that. I'm going to change that to radical form because we want radical form. So I'm going to make that the 6th root of x to the 5th all over x to the 6th, and that's my final answer. Alright, that's that for 50. A little bit tougher, but I did that on the board and talked about it a lot, so hopefully you already had that one before. Alright, 52 is the square root of 49x to the 5th. Remember, the book doesn't write index equal to 2. So I'm going to put that little 2 there. That means we're looking for perfect squares. .49 can be written as 7 squared. I'm going to take x to the 5th. Those are 5 x's. I'm going to rewrite it as x squared, and x. All right. Now, anybody who has a 2, all little 2's cancel. So this little 2 goes away, so 7 gets to leave jail. This little 2 goes away, so x gets to leave jail. This little 2 goes away, so x gets to leave jail. We're left with the square root of x. So my final answer is 7x squared, square root of x. If you want to translate it, you could translate it to 7x squared times x to the 1/2. And if you really wanted to go further, which we'll talk about a little bit tomorrow, is you can make that 7x to the 3/2. So if you have 7x to the 3/2, I might give you a half-point bonus. All right, 54. Because we have a n is equal to 3, I'm going to look for cubes. So I'm going to look at here. 4, not a perfect cube. He has to stay in jail forever. X cubed has the right key, so he gets to leave jail as x. He's gone. I'm going to rewrite y to the 5th as y cubed, y squared. He has the right key, so he's gone as y. And what stays on the inside is just this 4 and that y squared. 12, not perfect. Not a perfect cube. Y squared, not a perfect cube, so they have to stay in jail forever. Now I'm going to combine my radicals. So, because they both have little 3's, because that and that match, I can multiply this, x, y, 4 times 12 times y squared, xy cube root of 48 y to the 4th. Now, if I look at my perfect cubes, 48 is not perfect, but 8 and 6 turns into 48. 8 is perfect. So I'm going to rewrite this as x, y, cube root of 2 cubed times 6, because that's 8 times 6. Y to the 4th, I'm going to rewrite as y cubed, y. So I'm going to say times y cubed, y. And anybody with a 3 gets out of jail. So 2 gets to leave, y gets to leave. So this is my second y that gets to leave, because I already had one outside. That's why it's y squared. And what's left on the inside? 6 and y. Notice I made a noticeable difference between this little 2 with the y and that little 3 with the n. That's your final answer. Okay? And that's it for 54. All right, in 56, we have to remember, what does it mean to be simplified? If to simplify it, you can't have any perfects, and you can't have a radical on the bottom. All right, so I'm going to start with the bottom first. I'm going to pretend like the bottom is just 52. I'm going to cover up the negative 3. So I'm going to look at the bottom first. I'm just looking at the bottom, and I see 6 is bigger than 5. So I can rewrite this as x to the 5th and x. X gets to come out of jail, so I get negative 3. X to the 5th comes out of jail. I have the 5th root of x. So this guy stayed in jail. That's this guy right here. All right. Now, I know I have to multiply. I pick the 5th root to start because I see a 5th root right here. So I make those roots match to begin with. I would like to have x to the 5th. That's my goal. I would like to have that because then the radical goes away. So I look and I say, I have 1x. How many more x's do I need to have? 5 x's, so I put x to the 4th here. Whatever I put on top, on bottom, I have to put on top. Because this whole thing must equal 1. I choose this circle. I pick whatever I want. I can put anything in there I want. But it has to equal 1. And this one does, because the top and bottom match, so the top becomes minus 3, fifth root of x to the fourth. Now, those cancel, so the final answer is minus 3 fifth roots of x to the fourth all over x squared, and that's my final answer. All right. If you wanted to, you could rewrite this as negative 3 times x to the 4/5. If you did that, I will probably give you a half-point bonus if you mention that I said something in the video about it. So, moving on. Alright, 58. The first thing I'm going to do is remember that's a little 2, and I'm going to put the radical to the top and the bottom. So I'm going to put that to the top and the bottom. I'm going to make the square root of 20x cubed y squared all over the square root of 9xz cubed. Alright, radical to top and bottom. Now the next thing I do is I got to look for perfect squares. I use my numbers 1, 4, 9, 16, 25. 20 is not on that list, but 4 goes into 20. It's 4 times 5. So I'm going to think about it as 4 times 5. So I'm going to rewrite this as the square root of 2 squared, because that's 4, times 5. So this 20 turned into 4 times 5. X cubed is going to turn into x squared and x. And y squared is already perfect, so it's going to stay the way it is. Now the bottom, 9 is a perfect square. It's right here. So I'm going to rewrite this as 3 squared. X I can't do anything with, so I just write it as x. Z cubed, I write it as z cubed. Z squared times z. Now anything with a little 2, gets to leave the radical. Alright? So z gets to leave the radical. So the top turns into z on the outside. X gets to leave the radical. Y squared. Y gets to leave the radical. And that leaves me with 5 and x inside the radical. Now the bottom, 3 gets to come out of the radical, because he has a little 2. Z gets to come out of the radical. And I'm left with x times z. Now remember, I still can't have a radical on the bottom, so I'm going to take this to the next page. I'm going to write that next page. Okay. Now, remember, there's no radical allowed on the bottom. So I need this x and z to go away. Now remember, there's a little 2 there. So I'm going to multiply by the square root over the square root. Now I have 1x. I would love to have 2, so I put another x there. I have 1z. I would love to have 2, so I put 1z there. Whatever I put there, I put on top, because remember, this has to equal 1. So now I multiply across the top, multiply across the bottom, I get 2xy. Radical becomes 5x squared z all over square root of x squared of 3z x squared z squared. Now, once again, same thing, little 2's get to come out of jail, so this x gets to leave. So it becomes 2x squared y radical 5z all over 3z squared, because that z gets to leave, times x. Last thing, I have an x on bottom, I have an x on top, so one of those cancel to make that go away. So your final answer is 2xy radical 5z all over 3z squared. And that's it. A little bit complicated, but we got through it. It's going to get easier now. Alright, 60. You have 3 fifth roots x plus 9 fifth roots x. Remember, like radicals, same index. So I add 3 and 9. My final answer is 12 fifth roots of x. That's it. All right, 62. We have negative 7 cube roots of y plus 16 cube roots of y. Remember, like radicals, same radical, same index, same stuff on the inside. They have to be exactly the same. So I get minus 7 plus 16 is 9. That's 9 cube roots of y. And that's it. That's it. All right, 64. Once again, you got to have like radicals. Remember, those are both little 2s, so since they have the same index, I'm just going to do x and minus 2. So my answer becomes x minus 2 square root of 9x cubed minus x to the 5th. And that's my final answer. All right, 66, we're dealing with a rectangle, and we're talking about perimeter and area. Remember, perimeter is equal to 2 times the length plus 2 times the width. So the length is x cubed, so I put p equals 2 times x cubed plus 2 times 2x to the 2/3. So when I multiply this, I get p equals 2x cubed plus 4x to the 2/3. Since that has a plus sign in the middle, I'm going to add these, and I get 6x, and I'm going to multiply those exponents to get squared. 6, because 6 times 2/3 equals 2. So that's my final answer for perimeter. Area. Area is equal to base times height. So I say area equals to base, which is x cubed, or you could say length times width. And the height is 2x to the 2/3. Area equals x times 2x is 2x, and 3 times 2/3 equals just 2. So I get 2x squared for area. So there's my perimeter, and there's my area. 2 answers. Moving on. All right, 66 a little bit, or I'm sorry, that's a 68. 68 is a little bit longer because we have the perimeter of a triangle. The perimeter triangle is side A plus B plus C, but to find C, you need to know Pythagorean Theorem, which is a squared plus b squared equals c squared. And to find c, you take the square root of everything, so c equals the square root of a squared plus b squared. So I plug in a. I have a is 3x to the 1/3 plus 4x to the 1/3 plus c, which is the square root of 3x to the 1/3 squared plus 4x to the 1/3 whole thing squared. Now, I can add those together pretty easy, and I'm going to rewrite this. Hold on. Now, this turns into 7x to the 1/3 inside the radical. That little 2 goes to the 3, makes it 3 squared, which is 9. So it becomes 9x to the 2/3 plus 16x to the 2/3. That becomes 7x to the 1/3 plus the square root of 25x to the 1/3, or 2/3. 25 comes out. It becomes 7x to the 1/3 plus 5 square roots of x to the 2/3. So you got to remember, square root means 1/2. 7x to the 1/3 plus 5x to the 2/3 to the half. Well, half of 2/3 is 1/3. So I get 7x to the 1/3 plus 5x to the 1/3 gives me 12x to the 1/3. That's the perimeter. So perimeter is much more difficult for this one. A lot of more work. Area is much simpler because area is 1/2 base times height. Well, area is equals 1/2 base is 3x to the 1/3 times 4x x to the 1/3. I'm going to multiply all the numbers together. 1/2 times 3 times 4 is 6. X third, and x to the 1/3 is x to the 2/3. Because remember, means you add exponents. So your other answer could be, or you could have 6 cube roots of x squared. And that's it. 70 through 80, follow the rules we know, don't overthink it. Like 70, for example, x to the 0.5 times x squared. They're multiplying, so you add them, x to the 2.5. Since they gave you a decimal in the original problem, you can give me a decimal answer. 72. X to the 6th, y squared, all to the negative 0.75. Well, negative, that negative exponent means I move it downstairs. So I have x to the 6th, y squared to the 0.75 positive now, which gives me 1 over, I multiply 70.57 by both, I get x to the 4.5, y to the 1.5. 74. I have x to the 5th, y to the negative 3, all to the negative 0.25. Remember, negative exponent, move it downstairs, so I have x to the 5th, y positive 3 to the negative 0.25. The negative sign tells me to flip it, so I get y cubed over x to the 5th to the 0.25 positive now. So my final answer is y to the 0.75 over x to the 1.25. Hard to read, but I'm trying to rush this in. 74. Alright, first thing I'm going to do is I'm going to take the little 2 to both. I get 10x to the 0.6 plus, remember, the 2 goes to both, so it's 16. X to the 0.6. Now they match, so you end up with 26. X to the 0.6. And that's it for 76. 78. I get x to the 5 radical 3 over x to the 2 radical 3. Matching bases, so I subtract. I get x is equal to 5 radical 3 minus 2 radical 3. X, not equals, so it's equal to x to the 3 radical 3. And that's it. Alright, 80, the 2 is going to go to both. So I get x to the 2 pi over x to the 2 pi radical 3. Now, I have matching bases, so I make this 1x to the 2 pi minus 2 pi radical 3. Well, this is over 1. I can't subtract them unless they have 3, so I multiply the top and bottom by 3. I get x to the 6 pi over 3 minus 2 pi over 3. So I get x to the 4 pi all over 3. If you put it in radical form, you can't get a bonus point, or half bonus point there. But you got to mention I said so in the video. Alright, 82a. I'm going to break this down, and I'm going to talk about why an absolute value will show up at the end. So 32 is not a perfect to the 4th, but 2 to the 4th is. So I can write it as 16 times 2. X to the 4th gets to come out. Y to the 5th can be broken down into y to the 4th and y. So 16 comes out as 2. X to the 4th comes out as x. Because that's an even exponent, and it came out as an odd exponent, that's why absolute value shows up. Y's come out as 1y. So, and what's left in GL is 2 and y, so I'm left with 2y. That's it. Alright, 82b, you don't have to worry about the absolute value because it's an odd n and the x stays even. So I just rewrite x to the 5th as x5, x5. So x comes out x squared, y comes out x squared, y is your final answer. That's it. Alright, 29, I'm going to take 2/3 to everything. So I'm going to make this 8 to the 2/3, x, 3 times 2/3 is 2, y to the 7th is 14/3. Now, I'm going to keep this x as 6/3 and not 2, because then they all have little 3's. Since they all have little 3's, I can make it 1 cube root. Then I'm going to rewrite everything to make it perfect cube. Everything canceled.